So let's talk about the stations. Again, thermometer, you got the one that you've brought, along with the homemade one that you have actually created. We're just going to use the straw as an example. I can use any of the other straws if I wanted to. Okay. We're going to be able to stick your homemade thermometer in the water, and we're going to take the real thermometer and stick it in the water. Part of this is you can place it however you want to get an accurate reading. In the competition, the actual real thermometer needs to be facing the judge so that we can get an accurate reading. You are going to take your thermometer hooked up to either the calculator or your laptop and get a reading. You have 2 minutes to be able to give us a reading. We need an audible reading, and we actually need to see the actual written display so that you're not making up numbers. From that, we're actually looking at the real reading. We will write down the variance difference between them, the accurate one versus yours, and then we'll calculate the score after everything's over to figure out what's what. At the same time, you're gonna have an LED that's on your actual breadboard. We need to see what that light is for that particular temperature reading. Note, all lights and temperatures that correspond to where you are, your stations, they'll be predetermined at the beginning of the event. Your event leader will put on a board and say, 30 degrees, this is an example by the way, 30 degrees must register at a red light sensor, red light display. So whatever the range is between 30 and whatever the person may say, 30 or 40 degrees Celsius, must identify a red light. That is the light that must shine during that time frame. That is the actual change in the code that you need to do when you come to the competition that morning or that afternoon when you show up. All right, 4 stations. So we're gonna have 4 different temperature ranges: station 1, station 2, station 3, and station 4. So part of this scenario is you could actually have all 4 stations being operated by the students because this takes 2 minutes per station max. If you do that, you need to make sure you have enough space. So that's one reason why we don't have all 4 cups set up here. If I've got a laptop or an actual calculator, I don't want too many people to be huddled in between each other trying to get to the stations. So they'll read them out. Normally you would have a judge on each side. So judge here to do these 2 stations, you come around. You have a judge here to do these 2 stations. All the judge is doing is writing down the 2 temperatures, the one that is predicted, the one that is accurate, and the actual light. What light was displayed. Once you finish these 4 stations, the students can go back and finish their actual written test. If they've already finished the written test, they can leave. Take everything with you and leave, okay? Depending on how many teams you have, you'll need to rotate through these 4 stations. But this really is the actual intensive part of the actual grading portions of the event itself. So make sure you have available water. Let's talk about the water sources. So this is just regular good old water that you would get out of the actual tap here. Likelihood, most event leaders need to have 2 things with them. They need to have ice, and they need to have something similar to a coffee pot that actually boils. You could buy one of these at a Walmart, Target, whatever, but you need to have a very high temperature setting for the actual water. Be careful. Let's make sure it's not scalding, something that could actually hurt the students. But we do need to have something that is going to be way above room temperature in terms of measurement. That way, at least one station is high temperature. One station is very cold temperature in terms of actually having it filled with ice, and the other 2 can be intermediary ranges. The event leader gets to dictate what ranges they are, but they have to be replicable. So, case in point, if it's something below 10 degrees Celsius, that's probably gonna be full ice. If it's something above 85 degrees Celsius, that's probably gonna be something that came out of a boiling pot of water, okay? So, use common sense here for your temperature ranges, but that's exactly how you wanna set it up. 4 stations, light readings for those 4 stations written on the board, and then making sure you have an actual water supply that you can use for the students.
And how much do you have to account for variances? Like what should you be doing to these water sources since it's going to take all period?
Great question. So here's the beauty of all this in terms of how you judge it. Because you have a real thermometer being measured against an actual homemade thermometer, the variances don't make a huge difference in terms of accuracy of the actual water supply. That's number 1. Number 2, because we're doing this all period, you do need to have a warm water supply ready for the extreme temperature one to continue to refilling and repouring, just so that the temperature range matches the light, okay? So let's use 85 degrees Celsius again. And we've got that as this very hot warm station. If it gets below 85 degrees and the light does not come on, that's a problem. And you'll know that because you actually have an accurate thermometer to gauge off of. You need to refill that water pot to make sure that it is the correct temperature to enable that light to go on. Because what what you don't want to happen is you get to the end of the period and only half of the students were able to have their light turned on based on how their calculator or their program works.
And can they make modifications between the stations to their probe and their software?
So they can make modifications to the programming of their probe if something is wrong. They cannot make physical modifications. Now, that is almost a misnomer question for one reason. Part of it is you have 2 minutes per station. There's not a lot of time to recalibrate the actual equation that they're running. One thing we haven't talked about this is how they calculate temperature, and this is a very easy setup in terms of how we check whether a student's done the work themselves or not. The Arduinos that you're programming give out voltage. It is up to the students to calculate temperature. Okay, so when the reading's coming back to the TI calculator as well as to an actual laptop, it's a voltage reading. In the actual program that they're doing, they're going to calculate what the temperature reading should be in Celsius. Now, if they're smart enough, the display that they have on either machine will actually go ahead and give them the actual Celsius reading. And they have an equation in the book that they bring with them that tells us voltage to Celsius equation. And that is what they're trying to figure out in an actual slope. If they do everything correctly, they're going to figure out an equation, plot the actual dots on a graph from which they've tested, and create a slope equation that would match what the temperature readout is supposed to be. That's the correct way to do it. For those who are not paying attention at home and didn't read the rules ahead of time, if you use a pre-manufactured temperature gauge, it automatically is going to have the slope equation built into the actual instruction book. You cannot use that slope equation. And it's very easy for us as judges to figure out whether to use the slope equation because we'll be able to see the graph. A perfectly constructed graph is a telltale sign that the student did